Hey guys, a very good afternoon to all. So in this session we'll be talking about Rank-Rankl-Opg interaction. Okay, so I'm going to take this into two sessions. In the first session I'll be talking about what happens when a bacteria enters the body and how our body responds to it. In the second session I'll be talking about how this is going to influence the bone loss or bone resorption. Okay, so let me tell you two very important periopathogenic bacteria. Okay, Porphyromonas gingivalis and Aggregatibacter actinomycetum comitatus. You never forget these two bacteria, at least. Okay, so whenever a bacteria enters the body, previous sessions, which is the first line of barrier, epithelium, which is the first line of defense, neutrophils. Very good. So any bacteria similar to our fingers will have certain patterns for its recognition. Okay, so bacteria has certain patterns called pathogen associated molecular pattern. Okay, it is called as pathogen associated molecular pattern. So this pattern will be recognized by certain receptors which is present in our epithelium. Okay, say for example P. gingivalis, it comes in contact with the junctional epithelium or the circular epithelium. We have a lot of cells of innate immunity like natural killer cells, NK cells, dendritic cells, mast cells, tissue macrophages. Okay, so these cells will have certain receptors to identify this pattern. Okay, that receptor I'm going to call that as pattern recognition receptor. Okay, because it is going to recognize the pathogen associated with the pattern which is associated with the pathogen. So this pattern recognition receptor is called as toll-like receptors. Okay, so every bacteria will have certain patterns, and these patterns will be recognized by the cells of the innate immunity, and that receptor is called as toll-like receptor. So the toll-like receptor, once it identifies the PAMP, it is going to signal certain the certain cells of the body. Very simple. So when this PRR, the pattern recognition receptors, they identify the bacteria, what the first thing it will do is, it will tell the friends, see, some enemy has entered the boundary, kindly come and help. Okay, so it is going to send signals, and it is going to send signals to nuclear factor kappa B. Okay, this nuclear factor kappa B, which is stimulated by the toll-like receptor, it is going to produce what is called as the pro-inflammatory cytokines. See, I'm talking only about the basics. In depth, I'll take in separate classes. Okay, so once this bacteria is identified by the toll-like receptors, it is going to send signal to nuclear factor kappa B. And what does the nuclear factor kappa B produces? It produces lots and lots of pro-inflammatory cytokines. Okay, can you name some pro-inflammatory cytokines? Interleukin 1, interleukin 6, tumor necrosis factor alpha, interleukin 8. Interleukin 8 is also called as chemokine. Okay, it brings neutrophils to the site of inflammation. Okay, now these pro-inflammatory cytokines, they are going to bring, or it is going to stimulate the acute phase of inflammation. It is going to induce the cells of inflammation. Okay, so by this what happens, there is a lot of phases: transient vasoconstriction followed by persistent vasodilation. There's going to be stages. The neutrophil is going to migrate to the endothelium, where it binds to a lot of integrins, selectins. Okay, there's a lot of process, and it comes out. So the cells which is going to come out is neutrophils. So these neutrophils, with the help of interleukin 8, it is going to go to the site of the bacteria, and it is going to kill the bacteria. There are a lot of ways the neutrophils kills the bacteria. Okay, predominantly by oxygen dependent and oxygen independent. Okay, so what it is going to do, it is going to engulf the bacteria, it releases reactive oxygen species, it kills the bacteria, and after these bacteria are killed by the neutrophils, it is going to express these bacteria in the form of fragments on their outer surface with the help of a complex called MHC2 complex. Okay, these fragments of bacteria which are killed by the neutrophils, they express the fragments of bacteria. This is taken up by the T lymphocytes. So till now this is innate immunity, then the adaptive immunity kicks in. So T lymphocyte stimulate B lymphocyte, that is going to produce plasma cells, which in turn is going to produce antibodies, and also it stimulates memory cells. So next time the bacteria comes, it is going to kill fast. So normally this is what is going to happen, but remember this bacteria is not going to be killed easily like this. I'll tell you later, okay? So this is what the normal process of inflammation takes place. Bacteria comes, the bacteria has certain patterns recognized by toll-like receptors. These toll-like receptors stimulates nuclear factor kappa B, produces pro-inflammatory cytokines. Along with it produces prostaglandins, especially prostaglandin E2. It stimulates complement pathway, alternate and classical complement pathways. And what is going to happen? It is going to stimulate the cells of neutrophils. Neutrophils comes out, kills the bacteria, extends in the fragments MHC2 complex that is taken by the T lymphocyte, stimulates B lymphocyte, antibodies, plasma cells. Okay, so this is what the process of inflammation takes place, and the bacteria, it has its own virulent factors. It is not going to be killed easily like this. Okay, now what does these pro-inflammatory cytokines do is they also stimulate what is called as Rank-Rankl expression. Okay, so in the next session what you are going to talk about is how these pro-inflammatory cytokines stimulates, or what happens once these Rank-Rankl is expressed or stimulated. Okay, so thank you so much. See you in the next session.